Okay, silver chloride is AgCl, and that would be a solid. And that's an ionic compound. I know that because it's a metal and a nonmetal, silver and chloride. And you guys know that ionic compounds, if they're going to dissolve in solution, they dissolve as ions. So silver chloride, if it were to dissolve in solution, it would dissolve as silver ions and as chloride ions.
What page is it on?
747. So, what about calcium carbonate? Could you guys write something like this for calcium carbonate? Sure you could. Calcium carbonate's formula is CaCO3. And you would write what?
CaCO2 plus 2.
Ca with a plus 2 charge. Plus CO3 with a negative 2 charge, or the carbonate. Okay, both of these I have written as equilibrium reactions. Every equilibrium reaction has an equilibrium constant expression. What is that? How does it look? Products over reactants raised to the power of the coefficient. Okay? So for this silver chloride one, the KEQ, what would it look like? Products first over reactants. The products are the concentration of the silver ion times the concentration of the chloride ion. Over what? Over nothing, because the reactants are a solid, and we never include solid in equilibrium constant expressions. Just gases and aqueous. Okay? Guys, since this is a certain type of equilibrium reaction, it is a solid, and I'm showing how it dissolves in solution, the equilibrium constant has a special name. Instead of KEQ, it's called a Ksp. And the Ksp is a solubility product constant. Could you write the Ksp expression? That's what this is right here. Ksp equals silver ions times chloride ions. Could you write the Ksp constant expression for this calcium carbonate reaction? Yeah, that's easy. So the expression for the calcium carbonate reaction would look like that. Y'all, Ksps will always, like he was asking, it will always be just the products, never the reactants. Because they're all going to look like this. Solids going to make the aqueous ions. There's a list of actual, you know how we have that Ka table that I suggested y'all dog ear? Because every weak acid has a certain Ka at 25 degrees Celsius, right? We've got a Kb table. If you turn to page 748, there's a Ksp table. So it actually lists the compound, the name of it, it shows the equilibrium, and it gives you a Ksp. And you would have access to that table. I'll copy that very table off and give it to you on your test. Okay? Now, if we were going back to this silver chloride one, if I were going to set up an ice table, and let's say I take some silver chloride, solid, and I put it in water, and I'm going to see how much of it dissolves. For these ice tables, instead of putting X in the table, y'all know how we did the X's for the weak acids, remember? Your book uses S for solubility? Do you guys care? You mean do it like the book does it? Or, in other words, the book here would say S amount of this will dissolve and make S of this and S of this. Okay, you want to do X? That's fine with me. So at equilibrium, I have X and X, and I'm realizing that whatever I have in this column is not going to matter because it's not even showing up in this expression at all. So for silver chloride, if at equilibrium I have X amount of silver ion and X amount of chloride ion, then can't I say that the Ksp is equal to X squared? Because I plugged in the X for the silver and the X for the chloride, and I multiply them together, and I've got Ksp is equal to X squared. So, what is X? X is called the molar solubility. Molar solubility hopefully makes sense because you guys know that when I have these square brackets around something, doesn't that mean concentration? And what kind of units do we use for concentration? Molarity, right? So, but instead of saying like, oh, that's 1 molarity hydrochloric acid, don't we say 1 molar? So molar means solving for whatever the concentration is, the molarity. So if a problem said, what is the molar solubility of silver chloride, do you see how I would solve that? I have a table of KSPs, don't I? Right in front of me, page 748. So I go to page 748, look up silver chloride, and look up the KSP. Yeah, go ahead. 1.6 times 10 to the minus 10. Do y'all see that from the table? No. I'm going to plug the KSP in right here for KSP, and I'm going to solve for X. So I've got to take the square root of that to get the molar solubility. Do you guys see that? So I would say 1.6 times 10 to the minus 10 is equal to X squared. And when I solve for X, I have the molar solubility. 1.3 times 10 to the minus 5. 1.3 times 10 to the minus 5 molar. Got to put units on that one. Okay, so here's calcium carbonate, the next one. I've written the expression. Ksp is equal to the concentration of the calcium ion times the concentration of the carbonate ion. So what would the problem say? If it said, calculate the molar solubility of calcium carbonate then you guys would know simply by looking at the formula CaCO3 that's what the expression would look like, right? Ksp is equal to the calcium ion times the carbonate ion. Can you jump from that, Ksp is equal to calcium times the carbonate, straight to this? Ksp is equal to X squared. You can go straight to that. So when I say calculate the molar solubility, all I have to do is look up the Ksp of calcium carbonate, which is 8.7 times 10 to the minus 9. Set it equal to X squared. Solve for X. What do I do to solve for X? Square root of both sides. And so X is equal to what? 9.3?
3 to the negative 2.
Times 10 to the minus 5 molar. My negative got lost. So, you can be asked for a molar solubility, which is this. Molar solubility means the molar concentration. But guys, sometimes a problem will say, it won't say calculate the molar solubility. It might just say calculate the solubility of calcium carbonate, for example, since that's the one we just worked. That's different. If it says calculate the molar solubility, like the one we just did, that's asking for molarity. But when it says calculate the solubility, y'all, solubility units means grams per liter. When you take out that molar word, now I'm talking about grams per liter. So, I just solved this one. So I know that the molar solubility is 9.3 times 10 to the minus 5. Right? So I'm going to take that answer and I'm going to bring it over here. I know molar solubility is 9.3 times 10 to the minus 5. That is molar solubility, capital M. What does that capital M mean underneath that? What's that, Mitchell? It means moles per liter, right? So all I've got to do is go from moles per liter to grams per liter. Do you know how to do that? How do you go from moles to grams? It's the molar mass. So to show you what I'm talking about, I'm going to erase this M and I'm going to write that, break it down to moles per liter so you can see what I'm doing. That's the same thing as a capital M. So to get to grams per liter, all I have to do is get moles to cancel and convert it to grams. And I know how to do that, yes. I use the molar mass. So y'all figure out the molar mass of calcium carbonate. You knew it. The molar mass of calcium carbonate is 100.09. And so calculate, yeah, essentially